Some of you will do an entirely vector processing stream, and you'll get something that looks like this when you come to the end, which is a polygon data layer with individual polygons. And I've calculated first the average rainfall, or the rainfall, plus for each of these the net rainfall, and then the absorption, the surface absorption, and then I can calculate a runoff from that. And then from that runoff, I can scale it by area to get the total volume for the study polygon here. And you can see that some of these have very low volumes. This is a grassy area in a sandy field that absorbs most of the water. And then some of these have very high. And so if I have the Explorer here and click on this parking lot connected to a road, it should give me a value that's a fairly high volume here. And that's stored in this rainfall. That's the volume of runoff, and it's 168 cubic meters. Now this grid code is my watershed code. So up here in the north, I should have a grid code of 1, and this will be a lower volume, but it should have a different grid code. So yeah, there's a grid code of 1 and 51 cubic meters. And what I want to do is across those grid codes, I want to average the rainfall volume for those. So I have these sheds, and I want to basically, for each of these sheds, identify what's the total volume of all these polygons summed within the shed. And in my analysis, I've intersected the shed with my rainfall, net rainfall, and other layers, so I can calculate the volume just in that shed region there. Polygons are cut along this line. If I stop that, you can see there's the shed line that split this building roof into 2 different areas. And so here I'm trying to calculate then the sum for each shed of this rainfall volume using the shed numbers grid code. And I use the summary statistics tool for that. So if I double left click on the summary statistics, I'll basically identify the input table. In this case, it's going to be this V sheds intersection multi-part 2 table. So here's the V sheds intersection multi-part 2. Multi-part to 1 is a different table. My output table, I'll call that V sheds intersect multi-part. I'll just call this my shed sum out. And there are various fields and statistics. Now in this case, I want to do the sum of the rain volume. So I could calculate means or medians or other things, but in this case I want the sum. And the case field is the value I'm going to use to group by, and I can do by multiple, but here it's just grid code. So I'll go ahead and run that, and this will sum rain volume for each of the grid code types, so for watershed 1 and watershed 3, and it will output that into this shed sum out table. I should see that I have here my final values for the summary volumes, and they're in that range that I suggested they should be in, 1,000 for cubic meters for watershed 3 and almost 1,600 for watershed 1.